draw the most stable chair conformation of cis-1-ethyl-2-methylcyclohexane. Let's go ahead and begin by drawing our molecule. We have a cyclohexane, and we can number it 1, 2, 3, 4, 5, and 6. On number 1, we have an ethyl group. Sorry, I did not give myself enough space. And on carbon 2, we have a methyl group. Now, if it says cis, that means you have to draw both groups either on a wedge, or both groups could be on a dash. Up to you. I'm going to go ahead and draw both groups on a wedge. Next, what I'm going to do is I'm going to draw 2 chair conformations. So to draw the first chair conformation, we draw 2 parallel lines, and then we draw another 2 parallel lines overlapping. Then I finish my chair, and then my flip chair, I draw 2 parallel lines in the opposite direction, another 2 overlapping parallel lines, and close. Next, what I'm going to do is I will number each chair conformation. On this chair, I will start from carbon number 1, top right, 1, 2, 3, 4, 5, and 6. And on this carbon, I will start, my carbon number 1 is going to be here. This is really key to drawing these chair conformations, to make sure that when you draw the flip chair, your carbon number 1 is not this carbon, but 1 carbon away. So here, it will be here. 1, 2, 3, 4, 5, and 6. Another thing that you have to remember is that if my group is on a wedge, that means it's up. And if my group is on a dash, that means it's down. So on carbon number 1, my ethyl group is up. What is up on carbon number 1 here? Straight up. So I'm going to draw my ethyl group straight up. On carbon number 2, my methyl group is up as well. What is up on carbon number 2? It's diagonal, parallel to this line. Next, I'm going to go to my flip chair. What is up on carbon number 1? It's diagonal, parallel to this line. What is up on carbon number 2? Straight up like this. So these are my 2 chair conformations. Next, I'm going to identify the groups attached as either in axial or equatorial positions. Axial means straight up or straight down. Equatorial means at an angle. This is straight up, so this is axial. I'm just going to write A. And this group is at an angle. It's not straight up or straight down, so this is equatorial. Here, this group is equatorial because it's not straight up or down. It's at an angle. And this group is axial. How do I figure out which chair is most stable? Generally, groups want to be in equatorial positions. Equatorial positions are more stable. In this problem, I have 1 group axial and 1 group equatorial in both chairs. So what do? Notice that my groups are different. Here I have a bigger group, ethyl, in the axial position, and a smaller group, methyl, in equatorial position. Here I have a bigger group, ethyl, in equatorial position, and my smaller group, methyl, in axial position. I will choose the chair that has the bigger group in equatorial position. That will be the most stable chair. So I have to choose this one, because this is the conformation that has the bigger group in the equatorial position. This is Mayya. Please let me in the comments below. Let me know if you have any questions and what other topics are you learning in your organic chemistry class right now.